There's spray on down, brother. It's movie.
All right. Uh-oh. What are we starting on today?
We're starting on final semester review.
Semester exam review.
Yeah.
So you've learned all the new things. Okay, all that you have left is your semester exam review. Now you'll notice, obviously I gave you lots of work, room to work. It's kind of long, but we're doing it for 3 days. Don't do it for homework. Work on it in class. You'll easily finish it by the end of next week.
See y'all, she did. Joe.
Okay, easily. Please don't do it for homework or you'll just be bored for all of next week. Okay, so a couple quick things. Exams start when, you know?
Next Friday.
Next Friday. That means your late work is gonna be due that Thursday. Okay, so late work. Okay, it's gonna be due Thursday. That's December 14th. And we're just gonna say like midnight-ish. I'll still take stuff Friday, but I'm not tutoring the week of exams. I'm not doing a bunch of late work and test corrections. So really next week is it. That's for 2 reasons. Number one, if I have the baby during exam week, then you're not screwed because you didn't wait till the last minute. Okay, for sure I'll be here next week. That next week's where it could get a little rocky. Okay, so late work next Friday. Okay, midnight Thursday night, and then we're gonna just pretty much cut it off. Okay. Last thing, this is gonna be the questions we work together. You are required to do for a grade. Okay, but if you finish all of the remaining questions, you're gonna get an extra bonus of, I think we said 15 points on the semester exam. So everyone's exam will be curved a reasonable amount, but then you'll get an extra curve if you finish the remaining questions, which you'll have tons of time to do and should be pretty easy. Okay, good. So we're not gonna do all of them together, but we're gonna do a couple from each section. Go ahead and take a look at number 2. So number 2, we are finding the zeros. Remember that to find a zero, you take the equation and you set it equal to 0. So we have x cubed minus 6x squared plus 9x equals 0. Okay, we are solving by factoring. What do all of those terms have in common? They all have an x, and if they all have an x, that means I can take it out. So my x is gonna go to the front. What does that leave me with?
X squared minus 6x plus 9.
Okay, perfect. Equals 0. Okay, from there, I want to t-chart the quadratic. So I'm gonna pretend this x is in here. Okay, but I'm gonna t-chart this, which we haven't done in a while. So let's set up our chart right here. What is a times c for that polynomial? A being the first number, c being the last number. So it'd be 1 times 9, which is 9. And then I want to list all the factors that times to 9. I have 2 pairs. What are they? Okay, 1 and 9 and 3 and 3. Okay, then if the top of your chart is a positive, you want to add back to your b, which is what number? 6. So which of those are going to add to 6? 3 and 3. Now, what kind of 6 do I want? So I'm going to do both negatives. Very good. So remember, adding just means your signs are the same. They're either both plus, they're both minus. Okay, from there, we're going to have x minus 3 and x minus 3. Now, quick question. Why can I go straight to the parentheses with skipping where you like underline and all those kind of middle steps? Yeah, because at the very front it's a 1. So remember, if there's not a number here on the x squared, you can skip all of the grouping. We'll do an example of that later to remind you how. Okay, but for this one, we don't have to do it. Then also there was that x in the front. Okay, from there, if I have x minus 3 twice, I'm gonna rewrite that as x minus 3 squared equals 0. And then from there, I can identify my solution. And x on the outside means x equals what? 0. And then in x minus 3 in parentheses means that x also equals what? Positive 3. And remember, you're always switching the signs on this. So it says to sketch your graph. So let's come over here and do that. Remember that we found the x-intercepts. That's where your graph is going to hit the x-axis. So I know that it's going to hit at 0, which would be here in the middle. And at 1, 2, 3. So I have 2 x-intercepts, one at 0, one at 3. Okay, we talked about 2 different types of roots. You have what's called a single root and a double root. Okay, which of those 2 numbers, 0 or 3, is considered a double root? 3, because it has what on it in the equation? It has a squared on it, so that means that this one is a double root. And if you have a double root, there's something different that happens at the x-axis. Do you remember what it is? A bounce. Very good. Okay, versus for x equals 0, that's a single root. Single root. Which means that it's going to just pass through the x-axis. Okay, it's just going to pass through the x-axis. Now, look back at your original equation. What was the original power on x? X to the what? Up here, cubed x to the 3. Is that even or odd? Odd, so go ahead and circle odd here. And then remember that if it's odd, that means the ends go together or separate. Do you remember? They go opposite, they go separate. Okay, now you have 2 types of odd. If it's a positive odd, like this one, do you remember that it's going to start low and end high? Okay, but if it was a negative odd, it would start at the top and then eventually end at the bottom. So let's draw our graph. We're going to pass through 0. So start at the bottom. You're going to pass through 0. You're going to bounce at 3 and then keep going up. Now remember, this is a sketch. So if you put it in the calculator, it may look a little steeper. Okay, but that's the general shape. It's going to start low, pass through 0, touch at 3, and then keep going up. For your domain and range, is my, what's my domain? So I have an arrow on this side, arrow on this side. All real numbers. What about my range? How low does it go? Down forever and up forever, so all real numbers. Okay, now for your next question, it says f is increasing on 1 to 3. Now remember, we graphed this ourselves. Okay, so we don't know exactly how it looks, so will you go ahead and put it in the calculator so that we can check? We did a sketch, not quite accurately enough to answer part B. But increasing would mean that it's uphill. So we want to see, is that statement true or is it false? So I'm doing x cubed minus 6x squared plus 9x. If you wanted to type it in factored form, your graph should look exactly the same. Okay, here's my graph. Okay, pretty close to what we have here. Okay, and then we want from 1 to 3. So 1 would be here, and then 3 would be to here. So is it accurate to state that that part of the graph is increasing? No, what is it doing instead? Decreasing. So we're gonna put false for that. Okay, so from 1 to 3, my graph is actually downhill, so I would say that is wrong. Okay, last little bit of this is end behavior. So let's do the left end first. For the left end, what is X approaching? Infinity or negative infinity if I'm working to the left of the graph? Negative infinity. And then what is Y doing? Pointing up or down? Pointing up or down inwards. What's this end doing?
Down.
Down, and down would be which one? Negative infinity. Okay. So that means the left end points down. Okay, and on your exam, it's not gonna say it in words, it's gonna say it in symbols. Okay, but that's what this would translate to. Okay, for my other end, what is X approaching? Positive infinity. And which way is that end pointing, up or down? Up, then my Y is also going to positive infinity. Okay. Questions on that? All right, go ahead and turn the page, please. I think we're gonna do maybe 3 more. Okay, next one says to find the zeros. But you'll notice that you're finding both real and imaginary. So I'm a little worried that some of you might have forgotten this. That's why we're gonna do this one. So take your equation, set it equal to 0. So it'd be x cubed plus 25x equals 0. How can I factor that? Okay, divide what out? The extra x. That would give me x squared plus what? Equals 0. Okay, then when I get here, can I break this down with perfect squares? What does the symbol in the middle have to be for you to use the perfect square shortcut? Has to be a minus. So I'm gonna put here, you cannot use perfect squares on a plus. Okay, so remember, if you can't use perfect squares, that's okay. You're just gonna take that term and manually set it equal to 0 because you can't break it down. Now, for the x on the outside, can we go ahead and establish an answer for that right now? What is x on the outside gonna give us? 0, and that would be considered a real 0, so I'm gonna put that in this place. Okay, but for the one that won't break down, we're gonna have to solve that one by hand. So I'm gonna take my x squared plus 25, and I'm gonna set that equal to 0. Because this is gonna produce what are called imaginary zeros. So what will I do first to cancel out the plus 25? Minus 25 across. And 0 minus 25 is gonna give me negative 25. Then to get rid of the squared, I do what? Take the square root. And what is the square root of negative 25 gonna be? Yes, but what do you have to hide? Very good. So it's gonna be x equals plus or minus 5i. And remember that the I comes from the fact that you're trying to square root a number that's negative. Okay, also remember what we talked about, that imaginary roots always come in pairs. If 3i is a root, so is negative 3i. If 5i is a root, so is negative 5i. They always come in twos. Okay. From there, you're asked to sketch the graph. So I know that I'm gonna have a 0 at 0. Or an x-intercept at 0. Is it an even or an odd originally? X3 is odd. And is it a positive odd or negative odd? Still positive, so it's gonna start low and high. So here's what it looks like in case you forgot. You're gonna go up through your 0. Remember, it's a pass because it's a single. And then the imaginary is where your graph is gonna turn back towards the x-axis, but then not make it all the way and turn. Okay, this is what an imaginary 0 would look like. Is that it would kind of like turn and head back towards the x-axis, but then not make it. Because if it actually crosses, you'd have more real zeros. Okay? So I'm gonna put imaginary 0 in graph. That's what it would look like. Okay? All right, we're gonna do 2 more examples and then you're gonna have some time to work. Take a look at number 4. Okay, you have some piecewise functions to graph. We're gonna do the second one. Do you remember the shape of a graph that has bars in it like this? It is a V shape, very good. Which way will the +3 shift the V? Left, right, up, down? To the left. What about the -1? Down. So I'm gonna go to the left 3 and down 1. I'm gonna set my first dot. That would be right here. And then remember that normally the slope is gonna be right here in front of the bars. None is listed, that means it's what number? What's your number that's there if it's not written? 1. So it's 1/1. So start right here, you're gonna graph your V. Up 1/1, up 1/1, up 1/1. Okay, then I'm gonna go the other way, up over 1. Across to the left. Okay, but then remember, when it's piecewise, even though you plot all those dots, you're only gonna connect the dots in the section of the graph that equation is in control. What section of the graph is that equation in control? Less than 0, which is gonna be from 0 to the right or 0 to the left? To the left. So I'm gonna connect my dots, here's 0, so here's my 0 dot, and I'm only gonna connect this way. Okay, and those other dots that I plotted, because they're past 0, they're not included in the graph. Okay, one more additional question for your endpoint. Should it be an open circle or a closed circle? That's gonna be okay. All right, then bottom one, I have an x² equation. We happen to remember the shape for an x². X is gonna be a line, what about x²? No. It's a, you know what it is. Yeah, it's a U, yeah. Get it, you know what it is.
Oh my God.
Okay, it's a parabola. Which way are we shifting it with the +4? Up, because it's not in parentheses, right? The parentheses is when you go side to side. So this is gonna go up 4. And then do we remember what the negative does? It's gonna flip it. So instead of your U opening up, it's gonna open down. Yeah. So let's do that. Go up 4. Notice I'm using a different color so I can tell which dots are which. Okay, so I'm going up 4. And then I'm gonna go over, down 1, over, down 3. And then over, down 1, over, down 3. So the dots I'm highlighting in yellow are for the parabola. Some of them overlap. Okay, now notice I'm plotting 5 dots, but I'm not necessarily going to use all 5. Where is the parabola in control for the graph? Only x is where? Greater than 0, which means I'm only going to connect the dots from 0 to the right. So that would be only this side. Okay, and those other yellow dots I end up not using. Let's talk about your circle. Open or closed if it has an equal to? Closed. I'm gonna go ahead and make that circle a little bigger. Oh, and I forgot to draw the open circle for the first one. It should be like that. Okay, we all good with that? Alright, the one other thing on your semester exam, obviously I didn't wanna make the review longer than it is, but you'll have other shapes. So across this bottom here, I'm just gonna have you write the main ones so that maybe you'll remember what they are. If it's a y equals mx plus b, what shape is that? That's gonna be linear. Okay, remember it could be uphill, downhill, b is the y-intercept, m is the slope. Okay, if it's an x squared, we just covered that, what shape is it? U. Okay, what if it's in the bars, what shape is it? A V. Okay, next one is gonna be square root x. Do you remember the shape of a square root graph? It's like a dot, and then it just arches to the side. And then there was one more, your step function. If it's y equals a number by itself, remember it's a flat line through that function or that number. So if it's like y equals 10, you would just put a step through 10. Okay, and there are other shapes on there, but those are the ones that are on there. The questions on that? You will have a formula chart, you won't be able to use the full review. Okay, we're just gonna do one more.
You will have well done.
You will not be able to use the review, but you will have a formula chart. Last one that we're gonna do together is number 8. Okay, and if you got all the way to this page today, you would be ahead of the game as far as completing the review by the end of next week. Number 8. All right, first question. Do you remember? So obviously this is all stuff we learned a long time ago. How do I find horizontal asymptotes? You did it for Hangman. Yes. Okay, Bobo.
You have an else? No, I don't. There's not.
Okay, horizontal asymptotes are Bobo, Bon, Betsy. Okay, now for this equation, which of those is gonna apply? It is gonna be a Betsy because it's an x squared versus another x squared. So then I'm gonna divide those front numbers. That's gonna be 2 divided by 1. And what is 2 divided by 1? That would be 2. Very good. So I want you to go ahead and graph that asymptote now. So I'm gonna come over here to 2. I'm gonna draw in a horizontal line through that value. And remember that for horizontal asymptotes, your graph is gonna get closer and closer to that at the edges of the graph. Okay, from there, every other feature you have to factor to be able to solve for. So let's start with the top. What can I do to the top to factor?
GCF of 2.
GCF of 2, okay. GCF divide by 2. What's gonna be left over when I take the 2 out? X squared and then? -9, very good. Now, that's not fully broken down. Can I break down x squared -9 again by perfect squares? Yes, because what's the middle symbol? A negative you can break down, pluses you can't. So what is the square root of x squared? And x, and what's the square root of 9? So it'll be a +3 and -3. Okay, remember for perfect squares, you're gonna do one of each. Okay, go back and take a look at the top for me, please. It was x squared plus 4x plus 3. What can we do to the bottom? E-chart. So I'm gonna put my chart up here in the corner. Okay, so my T chart is gonna be 1 times 3, which is 3. And then there's only one way to multiply to 3. What do we get? 1 and 3. My numbers need to add back to a 4. Do they? Yes. And can I go straight to my factors? Yes, because I don't have a number on the x squared. So it'll be an x plus 1 and an x plus 3. Okay, you have your equation all the way factored. How do I find the holes in the graph? Okay, so let's write through the holes cancel. Where will I find the vertical asymptotes? Top or bottom? Bottom leftovers. And then where will I find the x-intercepts? X-intercepts are gonna be on top. And remember that a 0 and an x-intercept are the same thing. They're synonyms. Okay, so x-intercept would be the top. So what will cancel out? Look at your factored form now. The plus 3s, that means the whole will be where? -3 comma something, we'll find that later. My vertical asymptote is any x's left on the bottom. Will I have one? It's an x plus 1, so it's gonna be x equals -1. And then because that's an asymptote, I can go ahead and graph that right now. So -1's here. And so I know that my graph is not allowed to cross that value. Okay, my 0 is gonna be any x left over on the top. Do I have one? It's a -3, so I'm gonna switch it to a +3 comma something. And then how do I go back and find those two y values? What do I put in the calculator to find the y values? Just the stuff that didn't cancel. Do you remember that? So in your calculator, okay, go ahead and turn it on, open up your y equals, alpha link to get your fraction. You're only gonna put the parts of this that did not cancel. So on the top, I'll put a 2 and an x minus 3. And on the bottom, I'm gonna put just the x plus 1. Okay. But if you type in the original, you're gonna get extra errors that it won't fix for you to fill in the holes. Okay, then when you get to there, go into your graph. What is the y value for 3? 0. And what about the y value for -3? 6. Okay. So if you want to make maybe like a little note to find y values, put y equals 2x minus 3 over x plus 1 into calc check table. Okay, but remember, you're only putting the parts that did not cancel out. Okay, so now let's add those two features to our graph. -3, 6 is going to be here. Make sure it's a whole. And then my 0 or x-intercept is going to be +3, 0, which is here. Then remember to look at the rest of the picture. Now you can just hit graph because you already typed it in. So when I hit graph, I can now see that I have one piece of the graph that's up here. Make sure you hit the hole that you drew. And then your other piece of the graph is down here. Okay. All right, let's talk about the domain. How far forward does your graph go? Forever. How far backwards does it go? Forever. So if I put all real numbers, that means there's a dot at every single x value. Is that true? No, which ones got skipped that I couldn't touch? Can't touch -1. And what else could I not touch? Where's the hole in the graph at? -3. So for your domain, you would put all real numbers except we can't touch -1 or -3. And remember, the reason you can't touch those is because your hole doesn't count as a real dot. And then your X or vertical asymptote is another X that your graph can't intersect. So it'd be all real numbers except not -1, not -3. Okay, last of this is end behavior. What are both of the ends approaching? What Y value? Both of them are flattening out towards what value? 2. So as X goes to the left, my Y's are approaching 2. And same thing on the other side. Okay, remember that if your graph is flattening out towards a specific number, you put that number. But if it's just headed down, you put -infinity. If it's just headed up, you put infinity. Okay, questions on that? All right, I'm gonna give you most of the rest of class to work except for in a while, not right now. We're gonna do number 5 together. Please do not try number 5 on your own. That question's the worst. There is a question like it on the semester exam, but you'll need help with that one. So for right now, just skip number 5, don't scribble it out. Okay, but you should do all the ones that we skipped. Okay, through that page that we just did. Yes? The past is like a little sticky note. Sorry. Okay, and I'll just warn you, this particular question has some special formulas. That's why I'm doing it with you, that we like barely covered, but we did cover them and hopefully they'll look familiar. But take a look at your equation. You see it's equal to 2. What do I usually want the equation to be equal to? 0. Okay, very good. So let's start off by getting that equal to 0. How do I get rid of this 2 then? -2 minus 2. Okay, so now we have x to the 4 minus 2x cubed plus x minus 2 equals 0. That's step 1, is you always want it to be equal to 0 or you can't factor. Now, what type of factoring will I have to do if I have this many pieces? Can I t-chart? No. I have too many to t-chart. I can only have an A, a B, and a C to t-chart. What type of factoring? Put them in groups. So look at your first group. What do they have in common? How many x's? X to the 3. So I'm gonna x3 to the front. What's gonna be left over? Perfect, x minus 2. Okay, for my second group, I have an x minus 2. Those don't really have anything in common, but what can anything divide by? What number? A 1. So I'm going to just divide a 1 out of the second group since they don't really have much in common. When I divide by 1, though, that's going to keep the x minus 2 the same. From here, do my parentheses match? Yes. So what's my first factor? X minus 2. And then my second factor comes from whatever I'm leaving out. So it'd be my x cubed plus 1. Everybody good to there? Okay, from here, you can identify your first answer. If x minus 2 is an answer, then what is the first answer that we know? Okay, x equals positive 2. Now, remember that the original power tells you how many answers you should get. So this was originally an x to the what? 4. So I'm supposed to have 4 answers. So far we have 1. Okay, now we need to factor this. I want to draw your attention over here to the sum of cubes and difference in cubes formula. Okay, for perfect squares, these formulas are really easy. You just plus or minus whatever the root is. But if it's a perfect cube, you have to use these two formulas. Now, if it's a plus in the middle, then you're using the top formula. And if it's a minus in the middle, you're using the bottom formula. Which one will I use here? This is what I want to break down. The top. So I'm going to circle this one. Okay, first thing I have to do is find my A and my B, which are my perfect cubes. So if I take the cubic root of x to the 3, what would that root be? An x, very good. So I'm going to break this down to an x. Notice that then it's a plus. I'm following this formula I circled here. And then for my b, it's going to be the cubic root of the second thing, which was a 1. What's the cubic root of 1 though? It should still be 1. Think about how like 1 is its own square root. It's also its own cubic root. Okay, so that's your little short parentheses right here. Now we're going into this second one. It should be an a squared, which is now going to be an x squared, right? Because my a broke down to an x. Minus, I'm following this formula. I want my a and my b together. My a was an x, my b was a 1. What's x times 1? Still 1x. But notice what's the symbol next? A minus 1x. And then for my last term, I want a plus b squared. My b was a 1. What's 1 squared? Plus 1. Okay. So we had to use this formula to break down the perfect cube. Now we have our second answer. If there's an x plus 1 here, what's the second answer? Negative 1. How many am I supposed to find altogether though? 4. The last 2 are going to come from this parentheses. And I'll tell you that normally, how would I have you solve this? T-chart, but T-chart's not going to work. You can try it, but you're not ever going to be able to find numbers that do the stuff you need for that T-chart. So if T-chart doesn't work, T-chart does not work, then we also learned that quadratic formula always works. And you'll notice that right here. So my A, B, C, and we're going to use quadratic formula instead. So I'm going to put x equals negative blank plus or minus blank squared minus 4 blank blank all over 2 blank. Okay, and then remember that I'm going to plug those numbers into the formula after I've written it out. So the first 2 letters should be B. What number is B in the equation? Negative 1. So I'm going to put minus 1, minus 1. Under the square root, it's an A and a C. My A and my C are both what though? 1 and 1, right? And then all over 2A. What's my A? What's my A for this bottom blank? Another 1. Okay, from there, what part do you put into the calculator? And remember, not the square root, but the part under it, right? The discriminant. Good job. That's right. So will you put just this part into the calculator?
Good job, Gabby.
Very good job. No one in 4th period remembered the name. And I didn't even have to ask, and you knew. Okay, so type it in. You should get a negative number. Anybody got it? Negative 3, good. Now for the minus 1 in the front, it's a minus 1. So what kind of 1 is that really? So it's 1 plus or minus square root of negative 3 over what's 2 times 1 on the bottom? 2. Okay, this answer gives me what kind of numbers if it's a square root of a negative? Okay, listen. What type of answers is this gonna give us if our square root has a negative under it? Imaginary. So your last two answers are 1 plus or minus the square root of 3i over 2. Okay, and remember what we talked about when we did the unit with the i's in it? I's always come in pairs. So my first answer is 2. My second answer is -1. And then the plus or minus root 3i, that counts as the last two answers. Okay? All right. If you are worried that you might lose your packet, I would love to keep it for you so that you don't. So make sure your name's on it. If you want me to take your packet, I'll give it back to you next class. But if you lose it, you'll have to turn over. Jillian, I didn't realize how close we were to that class. I'm sorry.
So, in mind.
Anyone else want me to keep your packet?
It's 5 by